Guys, welcome to my YouTube channel. As we always do, we use our YouTube channel to solve mysteries and those calculus problems that are bringing problem to our lives. Now, our YouTube channel is called Solve Calculus, which I've just written on the screen. So you can be free to subscribe at any time. And make likes, view, comment. If you comment with a question, we'll of course do it. Now, today I want to look at something briefly on the concept of limits. And now, limit of a function is the value that the given function tends to be when the independent variable approaches a given value. Now, at times, this independent variable can approach a given value from both sides, that is the negative and the positive direction. Now, a simple number line has negative side and the positive sides of 0. So when value approaches a given value from the negative sides, then we call it a negative approach. When the value approaches that same, or an independent variable approaches the value from the positive sides, we call it positive approach. Now, to explain the concept of limit well, I'm going to use the diagram here, the graph of y is equal to x plus 2. Now, at any point when x is 3, if you substitute there, you are going to be getting the value of y as 5. So now, as x approaches 3 from any given direction, it can be from 10 towards 3 or from 0 towards 3. From 0 towards 3 is the negative approach, and from 10 towards 3 is the positive approach. So now, when x is approaching 3 from any given direction, then similarly, y will be approaching 5 from the direction that lies. For example, when you move from 10 to 3, the values of y will be ranging from the highest value towards 5. When you move from 0 to 5, the values of y will be starting from around 2 towards 5. So the values of y are approaching a given value, which is specifically 5, as the values of x approach 3. So the limit of the function is the value that y approaches. So for this case, our limit is 5. Our limit is 5. Now, let's look at something briefly on the laws of limits. Now, I have simplified all the laws of limit into 2. There are very many laws of limits. They are broken into smaller parts. Now I've simplified them into 2. The first law of limit is limit of a constant is equivalent to that constant. I've used an example. This is how we always write limit. Limit of 54 as x tend to 3, that is an arrow. Now, the constant there is 54. X is tending to 3, but the value is 54. So that limit is now going to be that constant value, which is 54. Now, that can be easily explained in an arithmetic manner. Now, we are saying 54 multiplied by x. 54 has an x, but the x is raised to power 0. So 54 x raised to power 0. That's what we have there. So now, when you substitute 3 into x, or as x, you are going to have 54 times 3 raised to power 0. Any number raised to power 0 is going to be giving you 1. So 1 times 54 gives you the value. That's where that comes from. Now, the second law of limit is limits involving more than one function can be split according to the sign between the function. Now, I've used some few more examples to illustrate that. The first example, limit as x tend to 3 of x cubed plus 7 x squared minus 1. Now, the sign between the function x cubed plus 7 and x squared minus 1 is a product. So we are going to split it into two, whereby we are going to be having the first one forming the first part multiplied by the second part. Now limit the second example there. Limit as x tend to 3 of x cubed plus 7 plus. Now this also you do the same, but now you change the sign. The sign in between is a positive, so you change the sign to plus. The last one, limit as x tend to 3 of x cubed plus 7 raised to power 5. This is supposed to be raised to power 1 over 5. Raised to power 1 over 5. Now 1 over 5 can be written as fifth root of something, so that can be written as you put out the root and then you write the limit the way it is inside the root. That's what I've done there. Those are the major laws of limit. I'll classify them into two, but the second law is always broken into smaller parts. Now we can now move on and look at techniques that we use in evaluating limits. Techniques used in evaluation of limits. Now there are 4 techniques that are used in evaluation of limit. There are actually 5. The 5th one is not more like a technique, but it is more of an application of the first 4 techniques. Now there are majorly 4 techniques used in evaluation of limits. The first one is direct substitution, we have factorization, we have L'Hopital's rule, we have rationalization, we have limits for absolute functions. Now I'm going to do them stepwise. In my next recording, in this recording, I'm going to do direct substitution and factorization. In my next recording, I'm going to be doing L'Hopital's and later rationalization and finally the 5th one. Now in direct substitution, you directly substitute the value that the limit tends to as the independent variable. If you haven't seen information, or you don't have information on what is an independent variable, refer to the first recording. I've actually numbered them. We have the first one, the second one, the third one. The first one is introduction and majorly the independent variable, domain and the codomain. The second one is composite functions, and we have very many examples done there, so you can easily look at them. Now, so in direct substitution, you substitute the value that the limits tend to as the independent variable. The independent variable here is x, so substitute the value that the limit tends to. The limit is tending the limit is x squared plus 6x minus 7, and x is tending to 3. So you substitute wherever you have x by 3. So now in this case we are going to be having 3 raised to power 2, and we'll be having plus 6 into bracket 3, and then we'll be having minus 7. As simple as such. That is direct substitution. And then you solve this using your calculator. You'll be able to get getting a value of 29 when you solve that using calculator. That's how direct substitution works. Very direct, very simple, and very easy. Just take the value of x there. Our x is tending to 3. I've said that is an arrow. You'll excuse me, please. Our x is tending to 3. So wherever you have x, substitute 3. 3 becomes 3 squared plus 6 into 3 minus 7. 3 squared is 9. 6 times 3 is 18. That is 36. Minus 7 gives you 29. Let me look at one more example. We will be having something like limit as our x is tending now to 4, and then we are having, and to use a fraction, So let's talk of x out of let me add something here. Now let's talk of x squared minus 5 out of 2x plus 7. Now in this one, when you are using direct substitution, the procedure remains constant. Just directly replace wherever you have x with the value that it is tending to. Now in our case we are having a value that whereby our x is tending to 4. So substitute this x squared with 4, so we'll be having 4 raised to power 2, 4 squared, and then we'll be having minus 5 divide by 2. Of course I tend to use bracket mostly. 2 into 4 plus 7. 2 into 4 plus 7. Just directly substitute. That is all about direct substitution. So when you do that, then you will be able to get something like 11 out of 15. As simple as such. That is direct substitution. Now there is one thing that you must understand in all questions related to direct substitution. Ensure you use, in all questions I mean related to limits, ensure you start from direct substitution. Ensure you start from direct substitution as the first method. Now let's move to the second method called factorization. Factorization, from the screen there I've written, factorization is used when attempting direct substitution and you get a value of 0 over 0. So anytime I've said the first method that you have to use is direct substitution, regardless of any kind of limit equation. On attempting, if you get 0 out of 0, then you use factorization method. Else, don't use factorization method. You will be taking time doing equation and you won't be reaching the answer when you use factorization method when the value is not 0 over 0. Okay, but if you get something like 3 out of 0, don't use factorization. But recall, anything divided by 0 divided by anything is 0. So when you get 0 out of 3, the answer is 0. But when you get 3 out of 0, that is infinity. So you attempt other methods. But when you get 0 out of 0, factorization method. Now example, we have limit as t tends to 3 of t squared plus 6t plus 9 out of t squared minus 9. Now this is also as simple as you see. The first step always used by direct substitution. I'm calling it d over s. D over s by direct substitution. So the first thing that you have to do is use direct substitution. You will be getting, our value there is 3, so our t is tending to 3, so you substitute 3 raised to power 2 plus 6 into 3 and then plus 9. And then now this is supposed to be minus, you'll excuse me, that is supposed to be minus, so that this is also minus. So now, and then down here we are having 3 raised to power 2 minus 9. Now when you solve numerator, 3 squared is 9, 6 by 3 is 18, and then 9. So when you add numerator and then you add denominator, sure enough you are going to be getting 0 out of 0. So because we have gotten 0 out of 0, then you easily move on and use factorization. So by factorization. So by factorization, you factorize both the numerator and numerator of the limit that you have. So we will be having limit, of course our t is tending towards 3. Now numerator can be factorized into our numerator can be factorized into t minus 3 squared, t minus 3 squared, and our denominator now I'm saying our numerator can be factorized into t minus 3 squared. I'll of course show that later. And our denominator can be factorized into, this is product of two squares, and it can be factorized into t minus 3 t plus 3. Now if you check well, t minus 3 will cancel with one of the t minus 3 in the numerator. So it means at the end we will be remaining with the limit as t tends to 3 of t minus 3 over t plus 3. Now also we are trying to say that this one can now be solved easily by use of direct substitution. So by direct substitution, then we are going to be getting t is 3, so 3 minus 3 is 0, divided by 3 plus 3 is 6, and I have just said any number divided by 0 divided by any number is 0, so the value there is 0. So that's how you do factorization, as simple as such. Let me do one last example, or I can give a simple exercise you can go and try. In case you find it difficult, just comment and we'll be able to check at it later. Now on the screen is the exercise. Limit as x tend to 1 of x squared minus 1 divided by x minus 1. The hint is very simple. Try direct substitution. If you get 0 over 0, then move ahead, factorize the numerator. From there I can see numerator is a difference of two squares. So factorize the numerator, cancel the values that can be cancelled, or the phrases or the functions that can be cancelled, and then try again direct substitution. You'll be able to get your answer there. Your answer in this case is going to be equal to, your answer is going to be equal to 2. So go and try out. If you don't get the answer equal to 2, please comment and we'll be able to check out and do it for you in another recording. Thank you for your time. Please subscribe, comment, then we'll be able to know whether we are satisfying some problems that have been facing students, or we are yet. Please take your time. Thank you and have some nice moments.